Good evening, everyone. Today we'll be discussing a little bit about one more rule about the differentiation of a function. And that's the chain rule of differentiation. तो chain rule में क्या होता है कि हमारे पास composite functions होती है. Like in this figure, we have a composite function. Composite functions क्या होती हैं? Suppose we have a function within a function. Like suppose we have y equals f of x, f of g of x. सच फंक्शंस को हम क्या कहते हैं? ऐसे फंक्शंस को हम कंपोजिट फंक्शंस कहते हैं. और कंपोजिट फंक्शंस का डेरिवेटिव निकालने के लिए हम चेन रूल का यूज करते हैं. We use chain rule to calculate the derivative of composite functions. हम एक एग्जांपल लेते हैं और एग्जांपल से सीखते हैं कि एक कंपोजिट फंक्शन का हम डिफरेंशिएशन कैसे करते हैं, कंपोजिट फंक्शन का डेरिवेटिव कैसे कैलकुलेट करते हैं. Suppose we have in the first example y equals cos of 2x plus 3. हमारे पास एक कंपोजिट फंक्शन है, that is y equals cos of 2x plus 3. तो इसका डेरिवेटिव कैसे कैलकुलेट करेंगे? It will be d by dx of y, that is d by dx of cos of 2x plus 3. हमें ये पता है कि cos x का डेरिवेटिव जो है that's minus sin x, it's minus sin of 2x plus 3, and the derivative of this part of the function, that's g of x, d by dx of 2x plus 3. And this will be the complete differentiation of a composite function. इस तरह से हम एक कंपोजिट फंक्शन का टोटल डेरिवेटिव कैलकुलेट करते हैं. It will be minus sin of 2x plus 3, derivative of 2x will be 2, and the derivative of 3 here will be 0 because 3 is a constant, तो constant का derivative जो है वो 0 होगा. तो फाइनली हमारे पास क्या आंसर आएगा? It will be minus 2 sin of 2x plus 3. इस तरह से हम एक कंपोजिट फंक्शन का डेरिवेटिव कैलकुलेट करते हैं यूजिंग द चेन रूल. इस रूल को हम कहते हैं चेन रूल. एग्जाम्पल नंबर 2 देखते हैं. एग्जाम्पल 2 हमारे पास है. हमारे पास फंक्शन है साइन ऑफ एक्स स्क्वायर प्लस एक्स क्यूब. Once again, we have to calculate its derivative. It will be dy upon dx. That's d upon dx of sine of x square plus x cube. Sin x का हमारे पास डेरिवेटिव कितना होता है? It's sine of the derivative of sine x is cos x. That is cos of x square plus x cube, and the derivative of x square plus x cube. So our final answer will be cos x square plus x cube. The derivative of x square will be 2x, and the derivative of x cube will be 3x square. Cos we know derivative of d by dx of x to the power n is nothing. It's nx to the power n minus 1. That's how we calculate the differentiation of polynomial functions. और एक एग्जांपल ट्राई करते हैं. y is equal to a sin of omega t plus y. हमारे पास और एक एग्जांपल है. Example 3. Y is equal to a sin of ओमेगा t प्लस 5। इस इक्वेशन को आपने एसएचएम में देखा होगा। ये डिस्प्लेसमेंट इक्वेशन रिप्रेजेंट करती है सिंपल हार्मोनिक मोशन को। इज अ डिस्प्लेसमेंट इक्वेशन ऑफ सिंपल हार्मोनिक मोशन। जब हम एसएचएम पढ़ते हैं, वेव्स एंड ऑसिलेशंस पढ़ते हैं, वहां पे हम एक स्पेसिफिक ऑसिलेशन पढ़ते हैं, दैट्स द सिंपल हार्मोनिक मोशन। और सिंपल हार्मोनिक मोशन में जब हम पार्टिकल के डिस्प्लेसमेंट लिखते हैं, दैट इज ऑफ द फॉर्म ऑफ ए साइन ओमेगा टी प्लस 5, जहां पे हमारे पास ओमेगा जो है एंगुलर फ्रीक्वेंसी होती है, और 5 को हम डिफाइन करते हैं एज इनिशियल फेज ऑफ द पार्टिकल, और टी हमारे पास टाइम है, और ए इज इज द एम्पलीट्यूड ऑफ पार्टिकल इन एसएचएम। पर यहाँ पे हम क्या देखेंगे, ए हमारा कांस्टेंट है, ए इज अ कांस्टेंट, ए कांस्टेंट है, ओमेगा भी कांस्टेंट है, एंड दिस फाई इज ऑल्सो अ कांस्टेंट। हमारे पास ए भी कांस्टेंट है, ओमेगा भी कांस्टेंट है, फाई भी कांस्टेंट है। द ओनली वेरिएबल इन दिस इक्वेशन इज टी, दैट्स द टाइम। अगर एसएचएम की बात करें, वहां पे टी हमारा क्या होता है, टाइम होता है। तो वंस अगेन इफ वी कैलकुलेट द डेरिवेटिव ऑफ दिस फंक्शन, अगर एसएचएम की बात करें, वाई डिस्प्लेसमेंट को रिप्रेजेंट करता है। अगर हम डिस्प्लेसमेंट का डेरिवेटिव लें तो हमें वेलोसिटी मिलती है। तो अगर हम इसका डेरिवेटिव कैलकुलेट करेंगे, दैट विल बी डी वाई अपॉन डी टी। हम एक्स के रेस्पेक्ट में डेरिवेटिव नहीं कैलकुलेट करेंगे, बिकॉज एक्स इज नॉट अ वेरिएबल हियर, द वेरिएबल हियर इज t. So we'll calculate the derivative with respect to t, and rest of the things are constant in this function. So it will be d upon dt of a sin of omega t plus 5। a हमारा कांस्टेंट है, बाहर आ जाएगा, d upon dt of sin of omega t plus 5। यहां से क्या होगा, sin of omega t plus 5, the derivative of sin theta is cos theta, cos x, the derivative of sin x is cos x, so we'll write it cos x, that's nothing but omega t plus 5, and the derivative of omega t plus 5, that's the chain rule। यहां से हमें क्या मिलता है, a ओमेगा टी का डेरिवेटिव टाइम के रेस्पेक्ट में कैलकुलेट करें, ओमेगा इज अ कांस्टेंट, टाइम का डेरिवेटिव इट्स टी टू द पावर 1, इट विल बी 1, so we'll get omega here, and phi is a constant and the derivative of constant is always 0, so we'll get a omega cos of omega t plus 5। So that's our final answer, that is a omega cos of omega t plus 5। तो इस तरह से हम जो है कंपोजिट फंक्शन का डेरिवेटिव कैलकुलेट करते हैं। हमारे पास और एक एग्जांपल है, that is x is equal to under root of t square plus 2। Example is x is equal to under root of t square plus 2। हमें इसका फर्स्ट डेरिवेटिव कैलकुलेट करना है t के रेस्पेक्ट में। हम एक काम कर सकते हैं, हम इस रूट को हटा के यहाँ पे एक्स स्क्वायर लिख सकते हैं, एक्स स्क्वायर प्लस टी स्क्वायर प्लस 2, और दोनों साइड से जो है टाइम के रेस्पेक्ट में डेरिवेटिव ले सकते हैं। टेक डेरिवेटिव ऑन बोथ साइड्स विद रेस्पेक्ट टू टी। टी के रेस्पेक्ट पे दोनों साइड से डेरिवेटिव लेंगे, तो फिर डी बाई डी टी ऑफ एक्स स्क्वायर प्लस डी बाई डी टी ऑफ टी स्क्वायर प्लस 2, डी बाई डी टी ऑफ टी स्क्वायर प्लस 2। एक्स स्क्वायर का डेरिवेटिव टी के रेस्पेक्ट पे इट विल बी 2x, एंड देन द डेरिवेटिव ऑफ x with respect to t, that will be dx upon dt। The derivative of on the RHS side, derivative of t square with respect to t will be 2t, and the derivative of 2 with respect to t will be 0 because 2 is a constant. यहाँ से हमारा t और t cancel out हो जाएगा. And from here our dx by dt जो हमें calculate करना था, it will be nothing t upon x. t upon x. t upon x. x क्या हमारे पास under root of t square plus 2. under root of t square plus 2. ये हमारे पास final answer होगा. So this is how we calculate the derivatives of composite functions using the chain rule. अब next concept जो हम discuss करेंगे about the derivatives, it will be its applications. Applications of derivatives. Applications of derivatives. हमारे पास अगर derivatives की application की बात करें, बहुत सारी applications है, खासकर physics में. There are a lot of applications of differentiation and the integration. हम velocity को अगर जब define first application is we calculate the velocity using the derivatives. Velocity को हम define करते हैं rate of change of position with respect to time. हम first derivative लेते हैं position का time के respect में, we get the velocity. या अगर हम velocity का derivative लें with respect to time, we get the acceleration. This is one more application. या हम force की जब बात करते हैं, we define force as rate of change of momentum with respect to time. That's the first derivative of momentum with respect to time. This is one more application. So there are a lot of applications with respect to derivatives, and these are some of the common applications जो हम frequently use करते हैं physics में. और इन्हीं applications को हम पढ़ते हैं in further chapters of our physics class 11 physics course. तो वन ऑफ द इम्पोर्टेंट एप्लीकेशन इज काइनेमेटिक्स में हम इसकी एप्लीकेशन देखते हैं. हमारे पास पोजीशन दी गई होती है और वी हैव टू कैलकुलेट द वेलोसिटी. व्हाट वी डू इज दैट पोजीशन, इफ द पोजीशन इज गिवन एज द, वी टेक द फर्स्ट डेरिवेटिव ऑफ द पोजीशन, वी गेट द वेलोसिटी ऑफ द पार्टिकल. And similarly, if we have to calculate the acceleration of the particle, what we do is that we are given with the velocity as a function of time, we take the first derivative of the velocity and we get to know about the acceleration of the particle. And similarly, मोमेंटम के रेस्पेक्ट में क्या है कि वंस अगेन मोमेंटम अगर वेरी कर रहा है एज अ फंक्शन ऑफ टाइम, इफ वी टेक द डेरिवेटिव ऑफ दैट मोमेंटम विद रेस्पेक्ट टू टाइम, विल गेट टू नो अबाउट द फोर्स एक्टिंग ऑन द पार्टिकल एट डिफरेंट टाइम्स. तो डिफरेंट टाइम्स में हमें फोर्स की बात करेंगे, डिफरेंट टाइम्स में हम एक्सेलरेशन की बात करेंगे, डिफरेंट टाइम्स में हम वेलोसिटी की बात करेंगे. एट द एंड ऑल दीज physical quantities like velocity, acceleration, force, and all these quantities, these are actually the applications of one of the important applications of derivatives in physics that we do in class 11 course. And we'll be doing this again, we'll be studying this again when we start the motion along a straight line. We will start the kinematics portion, we will start the dynamics portion, and in SHM as well. When we study the SHM, all the applications of derivatives will be there in all these chapters. So we'll take a simple example here. Suppose that we have been given that in this question we have been given that a position of a particle is given by x. It's actually x is equal to 3t square plus 4t minus 1, where x the position of a particle as a function of time. Now the question is asking us find its initial velocity and initial acceleration. By initial velocity and initial acceleration, we mean that the velocity of particle and the acceleration of the particle at time t equal to 0. जब भी हम initial velocity की बात करें, initial word use हो physics में कहीं पर भी, it always refers to when the time is 0, time t equal to 0. तो हम टाइम t इक्वल टू 0 की जब भी बात करेंगे, वी विल कॉल इट एज इनिशियल पॉइंट. और here we have to calculate initial velocity or initial acceleration. So we'll calculate the initial velocity and acceleration at time t equal to 0. So we know that velocity is nothing. It is if we take the first derivative of this function, position as a function of time. If we take the first derivative of this, we'll get to know about the velocity of particle at different times. So we'll be taking the first derivative, that's d by dt of 3t square plus 4t minus 1. Once again, we'll take the derivative of 3t square. The derivative of 3t square will be 3 will come out, and the derivative of t square, it will be 2t, and the derivative of 4t will be nothing, it will be 4, and the derivative of minus 1 is going to be 0. We already studied that d by dt of or d by dx of any constant is always 0, because constant does not change. So its derivative as a function of any variable will be always 0. So in this question, we can write that velocity is nothing, it's 6t plus 4. And we have to calculate the velocity of this particle at time t equal to 0. We'll put the value of t equal to 0 in this equation, and we'll get to know the velocity of the particle at time t equal to 0 is nothing. It's 4 meter per second. It is 4 meter per second. It is 4 meter per second. Now talking about the acceleration, acceleration is nothing. It's the first derivative, first time derivative. If we take the derivative of velocity with respect to time, we'll get to know about the acceleration of this particle. So it's dv upon dt. We have already calculated the velocity v as a function of time. That's nothing. 6t plus 4. 6t plus 4. We'll take its derivative. The derivative of 6t will be 6, and the derivative of 4 will be 0. So from here we can just see that acceleration of this particle is a constant. It's a constant. Means the acceleration of this particle will be 6 meter per second square throughout, right? So this is how we calculate the acceleration or velocity of particle when the position of a particle as a function of time is given. Now one more question here is, if position of particle is given by x is equal to t cube, it's actually x is equal to t cube minus 36t square plus 30t minus 1. So this is how the position of a particle varies as a function of time. We have to calculate, find its velocity when acceleration becomes 0. We have to calculate the velocity at a time when acceleration of a particle becomes 0. So we'll just calculate the velocity first. Velocity will be nothing. Dx upon dt. We'll calculate the first derivative. That will be v. So from here it will be 3t square. It will be 36 into 2t. So it will be 72t plus 30, and the derivative of minus 1 is 0. Now once again, if we calculate the acceleration of this particle, acceleration will be dv upon dt. It will be nothing. It will be 60 minus 72. That's going to be the acceleration of the particle at any time t. But the question is asking that we have to calculate the velocity of this particle when acceleration becomes 0. So if we put this acceleration equal to 0, the value of t at which the acceleration will be 0 is 72 upon 6, right? 72 upon 6. So it will be nothing, 6, 12. So after 12 seconds, the acceleration of the particle comes out to be 0. After 12 seconds, the acceleration of the particle comes out to be 0. So if we put time t equal to 12 seconds, time t equal to 12 seconds in the velocity equation. In the velocity equation, what is our velocity equation? It's nothing. It's 3t square minus 72t plus 30. So we'll just put the value of time here. 3 into 12 square minus 72 into 12 plus 30. So from here, 144 into 3 minus 72 into 12 plus 30. So this is how we will calculate the velocity of this particle when the acceleration of the particle is 0. So this is the final answer. This is the final answer that how we calculate the velocity of the particle when acceleration is 0. What we do is that we calculate the acceleration by taking the derivative of velocity and put that equal to 0. We'll get the time at which the velocity of the acceleration of the particle will be 0, and we'll try to find the velocity of particle at that particular time. So these are some of the applications that we do in physics with respect to the derivatives, and we'll be doing all these things again in the chapter like kinematics, motion in 1D, motion in 2D, right? So we'll be discussing all these things again. And one more important discussion about the application of derivatives is the calculation of maxima and minima. In the last lecture, we discussed that uh, there are always there can be a maximum or minimum points in a function. But the question is that how do we calculate, or how do we find those maxima and minima points for different functions? We'll just follow these steps to know about the maxima and minima. Suppose we have been given some function y here. What we'll do is that we'll just take the derivative of this function y. If we have to calculate the maxima and minima, maxima or minima for this function, what we'll do is that we'll just take the derivative of this y and put that equal to 0. Put that equal to 0. From this equation, find the values of x. Find the values of x. We find the values of x from this equation. There can be 1, 2, or many values of the x for which dy by dx is 0. And we just find all those values of x. And then what do we do is that suppose the values of x at which dy by dx is 0, let's consider that is x naught. Then to check whether the particular point represents a maxima or minima, what we do is that we just take the second derivative. We take second derivative of y. Take second derivative of y with respect to x and calculate. In the next step, what we do is that we calculate value of second derivative, that's d2y upon dx square at x equal to x naught. At x equal to x naught. Check if d2y upon dx square is greater than 0, then x equal to x naught is a point of minimum. Is a point of minimum. And if d2y upon dx square is less than 0, it is a point of maximum. Then x equal to x naught is a point of maximum. x is equal to x naught मैक्सिमा को रिप्रेजेंट तब करेगा जब हमारा सेकंड डेरिवेटिव एट x इक्वल टू x नॉट लेस देन 0 होगा, मींस इट शुड बी नेगेटिव. Now let's discuss all these points through this question and try to understand how we calculate the maximum or minimum for this function. हमारे पास ये फंक्शन दी गई है that y is equal to x square minus 4x plus 8. तो पहला स्टेप हमारा क्या रहेगा? We will calculate the derivative with respect to x. That's dy upon dx. It's 2x minus 4, right? And फिर second step हमारा क्या है कि we'll put this equal to 0. और यहाँ से हमें क्या मिलता है? Solution of this x dy by dx, that is x is equal to 4 upon 2, that comes out to be 2. तो हमारा solution जो है dy by dx का, that's x naught equal to 2. Now we'll find whether this x naught equal to 2 represents a maxima or a minima to calculate the second derivative. यहाँ से हम क्या करेंगे, हम second derivative को देखेंगे. We'll calculate second derivative, and second derivative we can easily see that the second derivative is 2, which is greater than 0. That is positive. 2 is a positive number, so it is greater than 0. So therefore x naught is equal to 2 represents a point of minima, represents a point of minima. It represents a point of minima. So there is only one solution. There is only one solution at which dy by dx is 0. So it represents a point of equation of y. We will get to know about the minimum value. We will get to know about the minimum value. तो minimum value हमारे पास क्या होगा फिर? Minimum value of y. Minimum value of y will be x square minus 4x plus 8. हम x naught को 2 पुट करेंगे. It will be 2 square minus 4 into 2 plus 8. So it's nothing. It's 4. So 4 will be the minimum value of this particular function. That's x square minus 4x plus 8. So that's how we calculate the minimum value of a function. Is there any maxima? No, there is no maxima in this function, because we just only got to know about the single point where the dy by dx is 0. That's at x equal to 2, and this point only represents minima. So there will be no point of maxima. No point of maxima. यहाँ पे कोई maxima point की बात होगी नहीं, because here maxima does not exist. Only minimum point exists. We have one more question. The question is y is equal to x cube plus 2x square minus 4x plus 2. We have to see whether this equation has a maximum points of maxima or points of minima. हम फिर से इसका डेरिवेटिव कैलकुलेट करेंगे. dy upon dx, it will be equal to 3x square plus 4x minus 4. So it will be 3x square plus 4x minus 4. And the derivative of this 2 will be 0. We'll just put this equal to 0. हमारे पास क्या है कि हमारे पास एक quadratic equation आ गई. हमारे पास एक quadratic equation आ गई है. The quadratic equation is 3x square plus 4x minus 4 is equal to 0. Now we have to solve this quadratic equation. We can solve this quadratic equation by two methods. Either we just directly go with the solution of quadratic equation, that's minus b plus minus under root of p square minus 4ac upon 2a. That's how we calculate the solution of quadratic equation. But the another method is there. We can go by the splitting of the middle term. If we just multiply this coefficient with this, it will be 3 into minus 4, it will be minus 12. It will be minus 12. So we'll just split it in this way. Suppose we'll just write here plus 6x and minus 2x minus 4, that will be equal to 0. So 6x minus 2x will be once again 4x, and 6x multiplied by minus 2x will be again 12x square. So from this equation we can just get the 3x as common. It will be x plus 2, and from here we can get minus 2 common, x plus 2, that will be equal to 0. Once again, we'll be taking x plus 2 as common, x plus 2, and we'll be left with 3x minus 2 equal to 0. From here, x will be nothing, it will be either minus 2 or x will be 2 upon 3. We got 2 points for which we can discuss the points of maxima or minima. So we try to find whether these points presents a point of maxima or minima. So we have 2 points here, minus 2 and 2 by 3. Now we have to check for both the points whether it represents a maxima or minima. What we'll do is that we'll once again calculate the second derivative. That's d2y upon dx square. That's nothing. If we calculate the derivative of dy upon dx, it will be 6x plus 4. Now let's check this derivative at x equal to minus 2. At x equal to minus 2. It will be 6 into minus 2 plus 4. That's nothing. Minus 12 plus 4. It will be minus 8, which is less than 0. So second derivative comes out to be less than 0. It means that our x equal to minus 2 represents a point of maxima. It represents a point of maxima. And similarly, if we check for x equal to 2 by 3, d square y upon dx square at x equal to 2 upon 3, it will be nothing but 6x plus 4 at x equal to 2 by 3. So it will be 6 into 2 upon 3 plus 4. So this will go, it will be nothing but 8, which is greater than 0, right? So our value, our point x equal to 2 by 3 will represent a point of minima. It will represent a point of minima. And we can also calculate the maximum value and the minimum value by substituting the value of x equal to minus 2 or x equal to 2 by 3 in y. We will get to know about the maximum or minimum value of the function. So that's how we calculate how we find the maxima and the minimum value of the function. The point is that the algorithm is that we just take the first derivative of the function, put that equal to 0. We find the points at which the first derivative is 0, and then we take the second derivative and calculate the value of the second derivative at all those points where our first derivative was 0. If the second derivative at those points comes out to be greater than 0, it will represent a minima. If second derivative comes out to be less than 0, it will represent a point of maxima. So that's the simple thing we have to do to find the maximum point or the minimum point. Now here's a one more question. The question is the slope of graph in figure at point A, B, C is MA, MB, and MC respectively. Then we have to check which of the following is the correct option. Let's Okay, so we have to check the slopes of this curve at points A, B, and C. We can clearly see that if I draw a tangent at this point at point A, अगर मैं इस point A पे tangent draw करता हूँ, it will be like this, and at point B, the tangent will be like this, and at point C, the tangent is just like this, just like this. We can clearly see the slope of this curve at every point. It is a negative slope. Negative slope at every point. हर किसी पॉइंट पे स्लोप जो है नेगेटिव है ऑन दिस कर्व, but we can see that slope is more negative at A. Slope is more negative at A than B and then C. It means that if the slope is more negative at A, it means it has lesser slope, less slope. If the slope is less negative at C, it means it has got greater slope than the points A and B. So from this, we can conclude that slope at C is greater than slope at B and then slope at A. So the highest maximum slope between the A, B, and C point is at point C. So the option second will be the correct option for this particular question. And here we have one more question here. A car moves along a straight line whose equation of motion is given by displacement, that is 12t plus 3t square minus 2t cube. We have to find the velocity of the car at start. At start means when the time t equals to 0. That's at this point we have to calculate the velocity of the car. What we'll do is that we'll take the first derivative of this car at this we'll take the first derivative of this displacement as a function of time, that's given as 12t plus 3t square minus 2t cube. We'll calculate the first derivative. So it will be nothing but 12 plus 3t square, it will be 60, and minus 2t cube, it's going to be 6t square, right? 60 square. So we'll just put, we have to calculate the velocity at time t equal to 0. We'll put time t equal to 0 in this and this also. So ये दोनों जो है 0 हो जाएंगे. We're left with 12 only. So 12 meter per second is the correct answer for this question. When the velocity of the this is the velocity of the particle, velocity of the car at time t equal to 0. So option 3 is the correct option for this question. So that's it for today. And in the next class, we'll be discussing about the integrals. We'll be discussing about the integrals and the applications of integrals. And till then, take care and goodbye.